Structures like reinforced concrete, where steel rebar is encased in solid concrete, can be represented by 1D rod or beam elements for the rebar inside solid 3D TET elements for the concrete. When setting up such a model, you have to take care to ensure that the mesh is contiguous and that the 1D elements connect with the 3D elements correctly. Let's take a look at how you can set this up in Femap. In this simple demo model, we have a solid block for the concrete that contains 3 internal curves that will represent the rebar. First, we need to create mesh points on the surfaces where the internal curves connect to ensure that the surface mesh will create nodes at the internal curve positions. Then we can mesh the internal curves to create rod elements in this case, as they will adequately represent the tension compression properties of the rebar. The next step is to mesh the bounding surfaces, and we can do that by selecting the Solid Mesh command, electing to surface mesh only. Selecting a hidden line view at this point will show that the meshing points have been picked up correctly. Now, with the curves and surfaces meshed in separate commands, there will be coincident nodes at the mesh points that will have to be removed. Now we can create the solid internal mesh using the Solids from Elements command, which will create a contiguous mesh correctly connecting the rod elements to the solid TET elements. Verifying the interior of a solid visually can be challenging, but in Femap we can use the grouping function to create a subset of the model that can be blanked off. In this case, we'll put the corner elements of the block into a group, such that when they're blanked off, one of the interior lines of rod elements will be revealed. And so you can see that a contiguous mesh has been created, correctly linking the internal rod elements with the solid TET elements inside the structure. To find out more, visit us at siemens.com/plm/Femap or call your local channel partner.